One of the ways that people can help is by adding to the knowledge base, and that's really basically anybody if the tooling is right. And the other way, I kind of want to ask you about your thoughts on this. So you've had, like you said, in government, and you have big clients. You had a lot of clients, but most of it is shrouded in secrecy because of the nature of the relationship, of the kind of things you're helping them with. So that's one way to operate. Another way to operate is more in the open, where it's more consumer facing. And so, hence something like OpenCyc was born at some point, where there's.
No, that's a misconception.
Oh, well, let's go there. So
All right.
what is OpenCyc and how was it born?
Two things I want to say,
Yes.
and I want to say each of them before the other, so it's going
Okay.
to be difficult. But we'll come back to OpenCyc in a minute.
Mm-hmm.
But one of the terms of our contracts with all of our customers and partners is knowledge you have that is genuinely proprietary to you. We will respect that. We'll make sure that it's marked as proprietary to you in the psych knowledge base. No one other than you will be able to see it if you don't want them to, and it won't be used in inferences other than for you and so on. However, any knowledge which is necessary in building any applications for you and with you, which is publicly available general human knowledge, is not going to be proprietary. It's going to just become part of the normal psych knowledge base, and it will be openly available to everyone who has access to psych. So that's an important constraint that we never went back on, even when we got pushback from companies, which we often did, who wanted to claim that almost everything they were telling us was proprietary. So
there's a line between very domain specific, company specific stuff and the general knowledge that comes from that.
Yes, or if you imagine, say, it's an oil company, there are things which they would expect any new petroleum engineer they hired to already know.
Right.
And it's not okay for them to consider that that is proprietary. And sometimes a company will say, well, we're the first ones to pay you to represent that in psych.
Yeah.
And our attitude is some polite form of tough. The deal is this: take it or leave it. And in a few cases, they've left it. And in most cases, they'll see our point of view and take it, because that's how we've built the psych system, by essentially tacking with the funding wins, where people would fund a project and half of it would be general knowledge that would stay permanently as part of psych. And so on.
So always with these partnerships, it's not like a distraction from the main psych development. It's in support of it.
A small distraction.
It's a small, but it's not a complete one.
Exactly.
So you're adding to the knowledge base.
Yes, absolutely. And we try to stay away from projects that would not have that property. So let me go back and talk about OpenCyc for a second. So I've had a lot of trouble expressing and convincing other AI researchers how important it is to use an expressive representation language like we do, this higher order logic, rather than just using some triple store knowledge graph type representation. And so, as an attempt to show them why they needed something more, we said, oh, well, we'll represent this unimportant projection or shadow or subset of psych that just happens to be the simple binary relations, the relation argument 1, argument 2, triples, and so on. And then you'll see how much more useful it is if you had the entire psych system. So it's all well and good to have the taxonomic relations between terms like person and night and sleep and bed and house and eyes and so on. But think about how much more useful it would be if you also had all the rules of thumb about those things, like people sleep at night, they sleep lying down, they sleep with their eyes closed, they usually sleep in beds in our country. They sleep for hours at a time, they can be woken up, they don't like being woken up, and so on and so on. So it's that massive amount of knowledge which is not part of OpenPsych And we thought that all the researchers would then immediately say, oh my God, of course we need the other 90% that you're not giving us. Let's partner and license Cyc so that we can use it in our research. But instead, what people said is, oh, even the bit you've released is so much better than anything we had. We'll just make do with this.
Yeah.
And so if you look, there are a lot of robotics companies today, for example, which use OpenCyc as their fundamental ontology. And in some sense, the whole world missed the point of OpenCyc. And we were doing it to show people why that's not really what they wanted. And too many people thought somehow that this was Cyc, or that this was, in fact, good enough for them. And they never even bothered coming to us to get access to the full Cyc.
But there's two parts to OpenCyc. So one is convincing people on the idea and the power of this general kind of representation of knowledge and the value that you hold in having acquired that knowledge and built it and continue to build it. And the other is the code base. There's the code side of it. So my sense of the code base that Cyc is operating with, I mean, it has the technical debt of 3 decades plus, right? This is the exact same problem that Google had to deal with the early versions of TensorFlow. It's still dealing with that. They had to basically break compatibility with the past several times, and that's only over a period of a couple of years. But they, I think, successfully opened up. It's very risky, very gutsy move to open up TensorFlow and then PyTorch on the Facebook side. And what you see is there's a magic place where you can find a community, where you can develop a community that builds on the system without taking away not any, but most of the value. So most of the value that Google has is still at Google. Most of the value that Facebook has is still at Facebook, even though some of this major machine learning tooling is released into the open. My question is not so much on the knowledge, which is also a big part of OpenCyc, but all the different kinds of tooling. So there's all the kinds of stuff you can do on the knowledge graph, knowledge base, whatever we call it. There's the inference engines. So there could be there probably are a bunch of proprietary stuff you want to kind of keep secret. And there's probably some stuff you can open up completely and then let the community build up enough community where they develop stuff on top of it. Yes, there'll be those publications and academic work and all that kind of stuff. And also the tooling of adding to the knowledge base, right? Like developing, there's an incredible amount, there's so many people that are just really good at this kind of stuff in the open source community. So my question for you is have you struggled with this kind of idea that you have so much value in your company already? You've developed so many good things. You have clients that really value your relationships. And then there's this dormant, giant open source community that, as far as I know, you're not utilizing. There's so many things to say there, but there could be magic moments where the community builds up large enough to where the artificial intelligence field that is currently 99.9% machine learning is dominated by machine learning, has a phase shift towards or at least in part, towards more like what you might call symbolic AI. This whole place where Cyc is at the center of, and then that requires a little bit of leap of faith because you're now surfing and there'll be obviously competitors that will pop up and start making you nervous and all that kind of stuff. So do you think about the space of open sourcing some parts and not others, how to leverage the community, all those kinds of things?
That's a good question. And I think you phrased it the right way, which is we're constantly struggling with the question of what to open source, what to make public, what to even publicly talk about.
Right.
And there are enormous pluses and minuses to every alternative. And it's very much like negotiating a very treacherous path. Partly the analogy is if you slip, you could make a fatal mistake, give away something which essentially kills you, or fail to give away something which failing to give it away hurts you, and so on. So it is a very tough question. usually what we have done with people who've approached us to collaborate on research is to say, we will make available to you the entire knowledge base and executable copies of all of the code, but only very, very limited source code access if you have some idea for how you might improve something or work with us on something. So let me also get back to one of the very, very first things we talked about here, which was separating the question of how could you get a computer to do this at all versus how could you get a computer to do this efficiently enough in real time. And so one of the early lessons we learned was that we had to separate the epistemological problem of what should the system know, separate that from the heuristic problem of how can the system reason efficiently with what it knows. And so instead of trying to pick one representation language, which was the sweet spot or the best trade-off point between expressiveness of the language and efficiency of the language, if you had to pick one, knowledge graphs would probably be, associative triples would probably be about the best you could do. And that's why we started there. But after a few years, we realized that what we could do is we could split this and we could have one nice, clean, epistemological level language, which is this higher order logic. And we could have one or more grubby but efficient heuristic level modules that opportunistically would say, oh, I can make progress on what you're trying to do over here. I have a special method that will contribute a little bit toward a solution. And so
for some subset of that knowledge.
Exactly. So by now we have over 1,000 of these heuristic level modules, and they function as a kind of community of agents. And there's one of them, which is a general theorem prover. And in theory, that's the only one you need. But in practice, it always takes so long that you never want to call on it. You always want these other agents to very efficiently reason through it. It's sort of like if you're balancing a chemical equation. You could go back to first principles, but in fact, there are algorithms which are vastly more efficient. Or if you're trying to solve a quadratic equation, you could go back to first principles of mathematics. But it's much better to simply recognize that this is a quadratic equation and apply the binomial formula and snap, you get your answer right away and so on. So think of these as like 1,000 little experts that are all looking at everything that Cyc gets asked and looking at everything that every other little agent has contributed, almost like notes on a blackboard, notes on a whiteboard, and making additional notes when they think they can be helpful. And gradually, that community of agents gets an answer to your question, gets a solution to your problem. And if we ever come up in a domain application where Cyc is getting the right answer but taking too long, then what we'll often do is talk to one of the human experts and say, here's the set of reasoning steps that Cyc went through. You can see why it took it a long time to get the answer. How is it that you were able to answer that question in 2 seconds? And occasionally you'll get an expert who just says, well, I just know it. I just was able to do it or something. And then you don't talk to them anymore. But sometimes you'll get an expert who says, well, let me introspect on that. Yes, here is a special representation we use just for aqueous chemistry equations, or here's a special representation and a special technique which we can now apply to things in this special representation and so on. And then you add that as the 1,001st HL heuristic level module. And from then on, in any application, if it ever comes up again, it'll be able to contribute and so on. So that's pretty much one of the main ways in which Cyc has recouped this lost efficiency. A second important way is meta reasoning. So you can speed things up by focusing on removing knowledge from the system till all it has left is like minimal knowledge needed to, but that's the wrong thing to do, right? That would be like in a human extirpating part of their brain or something. That's really bad. So instead, what you want to do is give it meta-level advice, tactical and strategic advice that enables it to reason about what kind of knowledge is going to be relevant to this problem, what kind of tactics are going to be good to take in trying to attack this problem, when is it time to start trying to prove the negation of this thing because I'm knocking myself out trying to prove it's true and maybe it's false, and if I just spend a minute I can see that it's false or something.
So it's like dynamically pruning the graph to only like based on the particular thing you're trying to infer.
Yes. And so by now, we have about 150 of these sort of like breakthrough ideas that have led to dramatic speed ups in the inference process. Where one of them was this EL-HL split and lots of HL modules. Another one was using meta and meta-meta level reasoning to reason about the reasoning that's going on and so on. And 150 breakthroughs may sound like a lot, but if you divide by 37 years, it's not as impressive.
So there's these kind of heuristic modules that really help improve the inference